Hello everyone, today we are going to discuss about a topic 51 geometric section called Circle Theorem under the GCSE topic revision guide. Under this topic there are 7 to 8 circle theorems there. So in your exam they might ask the reasons for your answers finding angles. So you have to memorize at least a brief idea about the circle theorem. After you understanding all the 8 theorems, then you need to work out a couple of questions to make sure in a circle theorem you can find an angle. After this one, the second topic is called circle theorem proof. So we are going to discuss the proof on a different video. So now in this video we are going to discuss about the theorems and some exam style questions. Let's look at the theorems now. Circle theorems. Theorem 1. Angle at the center is twice the angle at the circumference. If you see the angle in the center angle we call, which is a double the circumference angle. Theorem number 2. Angle subtended at circumference by a semicircle is 90 degrees. So you can see a line passing through the center is a diameter. If there's a diameter in the question, the angle subtended by the both ends of the diameter, which is 90 degrees. Theorem number 3. Tangents and radii meets at 90 degrees. So radius and tangents meet at 90 degrees. Theorem number 4. Tangents from a point have equal length. So if you draw a tangent, two tangents from a point outside of the circle, the length of the tangents, both tangents' length are equal length. We use this theory for a congruent triangle later on in the question. Theorem 5. Angles in the same segment are equal. So same segmented angle are equal. So from these 2 points here, the angles in the circumference are going to be equal to each other. Theorem number 6. Opposite angles in a cyclic quadrilateral add up to 180. So A add with C is 180, B add with D is 180. The last theorem is alternate segment theorem. So a tangent and a chord making angle X, which is a alternate segment angles equal. So that means if you go inside, this is going to be the same segment. Alternate segment means the opposite segment. That angle and the angle in between the chord and the tangent. So those two angles are alternate segment angles are equal. So if you look at the Y here, that chord, green color line is the chord and the blue color line is the tangent. That angle equal to the alternate segment angle here marked in Y. That's all the theorems now. Let's look at some questions. Hello everyone, this is the tutorial we are going to discuss in this video session. You can download this tutorial from our website at www.smarttutor.co.uk/worksheet.php. Under the Year 11 section, you can download this tutorial. Yearly membership of £24 allows you to download all the tutorials from our website. Let's look at the exam style question. Question number 1. Points A, B and C are all on the circumference of the circle or represent the center. DA and DB are tangents to the circle. Angle BDO 22 degrees is given. Work out the value of the X. So X is somewhere here, which is the ACB is the question. First of all, if you see these two triangles, they are going to be a congruent triangles because this is a 90 degrees one. So this is 90 degrees and this is 90 degrees. On top of it, the angle BDO, angle ADO is 22 degrees. So this is going to be 22 degrees as well. Before you say that that is 22 degrees, you need to say in triangle ADO, triangle BDO, the both triangles are congruent triangles, side, 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 because the both lengths are equal. This is radius and this is the common side, right? So all three sides are equal to all three sides. So both triangles are congruent. After you prove the congruent, these two angles are equal. So if this is 90 and this is 22, you can find angle OBD is 90 degrees because of tangent and radius. So you need to write tangent and radius meet at 90 degrees. Angle BOD, so BOD, this is going to be 180, take away 22, take away 90, which is 68. So if this is 68, this is going to be 68 as well. So once you find out 68 and 68, AOB is 2 times 68, which is 136. ACB is the half of the center angle. So ACB is half of 136, which is 68. So X is automatically becomes 68 degrees because the center angle double the circumference angle. So the answer for the X is 68 degrees. Question number 2. Points A, B and C are all on the circumference of the circle or represent the center, and angle AOB is 2x plus 28, angle ADB is 3x minus 70. Work out the value of X. So how to find out the X is, first of all, AOB is 2x plus 28, ACB is half of the AOB. So half of AOB is 2x half is X and plus 28 half is 14. So opposite angles add up to 180. So ACB plus ADB is 180. So opposite angles add up to 180. So x plus 14 plus 3x minus 70 equal 180. So add them together, 3x plus x is 4x. 14 minus 70 is gives minus 56. So you can take the minus 56 other side, becomes plus 56, which is 236. So 4x equal 236 is x is 59 degrees. So that is the answer for question number 2. Question number 3. Points A, B and D are all on the circumference of the circle. C represents the center. ADC is 33, ADC is 33 and BCD is 126. Find out the value of ABD. So this is the angle ABD is the question. BCD is 126 is given. BAD, so BAD is 63. Why is 63? Because center angle double the circumference angle. Opposite to that is circumference angle is half of the center angle. So half of 126 is 63. So BCD is an isosceles triangle. BCD, so this angle equal, this side equal to this side. So 180 take away 126 is whatever the remaining, divide by 2, which is 27. So this is 27. So if this is 27, altogether this angle is 27, 30, 60 degrees. 60 plus 63 is going to be 123. Take away from 180, the big triangle, which is 57. So you got this one 63, 60, and this is 63. And you can find out the ABD. ABD equal 180, take away 60, take away 63, which is 57. That is the answer for the question number 3. Question number 4. BDE are points on the circle O. ABC is a tangent. ABC is a tangent. BE is a diameter. So BE is a diameter. Angle DBE is 35 degrees. DBE is 35 degrees. So if this is a diameter, you know this is 90 degrees. Now first question, find the size of the angle ABD. So ABD, this angle, we know this is a 90 degrees altogether. 90 degrees take away 35 is going to be 55. So tangent and radius meets at 90 degrees. So 55. Find the size of the angle DEB. So DEB, this angle is going to be BDE is 90 degrees, BDE is 90 degrees because angle subtended in semicircle is 90 degrees. That is correct. Then in triangle BDE, 180 minus 35 and minus 90, which gives 55. Alternate method, this ABD 55 degrees is alternate segment theorem, so directly equal to this one. So you can say ABD and DEB are equal, which is 55 degrees, alternate segment theorem. That is the answer for the question number 4. Question number 5. PQT are the points on the circumference of a circle, center O. The line ATP, so ATP is 58 degrees, is given, and the line ATB in the tangent at the point T, angle ATP 58 is given. Now you need to find out how to do the OTQ. So OTQ, this is the angle in question. First of all, alternate segment theorem, you can say PTA, this 58 equal to 58. So that is 58. Now what you want to do is, it's an isosceles triangle. I have written here, triangle PQT is isosceles QPT. So QPT equal QTP equal 180 minus 58 divided by 2, which is going to be 162 divided by 2 is 61. So this is 61. This is 61. And this is going to be 61 as well. The base angles are equal. Now OTA is 90 degrees. 90 take away 58 is 32. 90 take away 58 is 32. So 32 take away from 61 is going to be 29. So 29 degrees is OTQ. So OTQ is 29 degrees. That is the answer for question number 5. Question number 6. The diagram shows a circle center OABC. Points on the circumference. DCO is a straight line. DA, which is the tangent to the circle. So if this is tangent, this is going to be 90 degrees. And this is a triangle now. So 90 plus 36 take away from 180, which gives this center angle 54. So that is the first question, why this is DOA. So AOD or DOA is the 54 degrees, as tangent and radius is 90 degrees, take away from 180 will give the 54. Now the second question is, work out the size of the angle ABC. ABC is a circumference angle. This is a center angle, this is a circumference angle. Half of 54 is 27 degrees. That is the answer for the ABC. So 54 divided by 2, 27 is the question number 6. Question number 7. The diagram shows a circle center OBDEF are points on the circumference. ABC is the tangent is given. ABD is 77. DEF, so DEF is 64. Find the value of angle BDF. So BDF, so this is the angle we need to find. That is in question mark, right? ABD, so ABD equal BED. Why? It's an alternate segment theorem. So alternate segment theorem means you found the chord and the tangent. So this angle equal to inside opposite alternate segment theorem. So this is 77. So you can written the 77. BEF, which is BEF is 77 plus 64, which is 141. So BEFD is a cyclic quadrilateral. So BDF plus BEF add up together 180. So if you have 180, this both add up together. Take away from 180, this 141 will give the BDF. So BDF equal 180 minus 141, which is 39. So that is the answer for the question number 7. So that is the end of our tutorial. I hope you do like the video. If you do like the video, please give us a thumbs up and subscribe to our channel to see all the upcoming videos. Thank you very much for your time.